Hello viewers, today we are going to see about LED advantages, class 12 physics NCERT syllabus. So if you look into page number 488, page 488, physics 12th standard, the last 5 points. So if you can see the 5 points. Let me explain all these 5 points. LEDs have the following advantages over conventional incandescent low power lamps. Incandescent lamp, you know, incandescent lamps, especially low power. No, we are not going for very high power like 60 watt like that. So assume a very low power incandescent lamp. The symbol is like this. Okay. Even a 0 watt lamp will have some power requirement. It operates with 230 volts generally. So the first point is, if you use LED, low operational voltage and less power. So as I already told you, incandescent lamps works with AC supply 230 volts 50 Hz AC. So the operational voltage here in this case is 230 volts, whereas LED low operational voltage, that means LED forward bias voltage, it depends upon the wavelength also, color also. So it emits out light. So the voltage across the LED roughly starts from 1.6 volt, it depends on the color, and goes up to 2 to 2.2 volts based on the wavelength. But anyhow, this is going to work with 230, whereas LED is going to operate with very low voltage. Not only it is operates with low voltage, the current through the LED will be roughly, say maximum it can be 20 milliamps. So the current through the diode will always be less than 20 milliamps. It depends on the power rating, so it will be in milliamps only. Even if you consider 2 volts, so power is equal to V into I. So V into I, 2 into 2, 40 milliwatt. If you assume 2 volts is the voltage across the diode and the current through the diode is 20 milliamps, we all know the power is equal to V into I. So what is the voltage? We assume 2 into current is 20 milli. So this will give you 40 milliwatt. Whereas here it goes in watts, 1 watt, 2 watt like that, 60 watt, 40 watt lamps like that. So low operational voltage and less power. So this is the first point. Next we will move on to the second point. The second point is fast action and no warm-up time required. Fast action and no warm-up time required. So the meaning of this is, the moment you switch on the power, when the switch is closed, the moment you close the switch is closed, the LED will glow. It won't take any time to warm up. Whereas if you see mercury vapor lamp, sodium vapor lamp and all, it will take some definite time before going into glow. But as far as LED is concerned, the moment you switch it on, it will start giving off light. So that's the meaning. So there is no, that is fast action and no warm up time required. For example, mercury vapor lamp like that, or even incandescent lamp, it will take some time. Here the time required will be highly negligible. You cannot distinguish, it will be in the order of nanoseconds. So no warm up required. The moment you switch on the circuit, the LED will start giving out light. So that is the second point. That means there is no delay at all. This will take some time. Second, this is the meaning for second point. Third point, the bandwidth of emitted light. BW means bandwidth of emitted light. Emitted light is 100 angstrom unit to 500 angstrom unit. Or in other words, it is nearly monochromatic. Or in other words, it is nearly monochromatic. Mono means single wavelength. So 100 angstrom unit, 1 angstrom unit, 10 power minus 10 meters. So it has a very huge bandwidth, starts from 100 angstrom unit to 500 angstrom unit. If you want to convert that into nanometers, you can do it. So 100 angstrom unit is 10 power minus 10 meters. So 100, you take pull out 110. 10 power minus 1 into 10 power minus 9 meter. So this will become nanometer. So 10 power minus 1 is 10 nanometer. So this starts from 10 nanometer to, there it is 500 angstrom unit. So 500 into 10 power minus 10 meter. So this can be written as 500 into 10 power minus 1 into 10 power minus 9 meter. So this is nanometer. So this will give you 50 nanometer. So from 10 nanometers to 50 nanometers is the bandwidth, and it is monochromatic. Monochromatic means single wavelength, very close to the single wavelength. Not multiple wavelength or multiple range of frequency. That's the meaning. Even if you choose for visual spectrum, LEDs like red, green, blue, Vibgyor range, even if you based on the material composition, it tries to emit very close to that wavelength. It will be in and around with that wavelength, but does not deviate from its center value. So that's the important difference between, whereas the incandescent lamp will have a range of frequencies around its center wavelength. So that's why we say the bandwidth of the emitted light is 100 angstrom unit to 500 angstrom unit. So this 100 angstrom unit is nothing but 10 nanometer, and 500 angstrom is nothing but 50 nanometer. And it is monochromatic. Monochromatic means first, if a LED is designed for a particular wavelength, it emits that wavelength alone, or it will be very close to that. There is no much deviation from its center wavelength. That's the meaning of this point. Next, fourth point. Fourth point is long life and ruggedness. See, the lifetime of incandescent lamps may be for 6 months or 1 year or maybe 2 years or 3 years maximum. But when you drop an incandescent lamp, the glass enclosing the filament, it will get damaged. Whereas when you drop an LED, nothing will happen. It is solid, nothing will happen. That's why we say ruggedness. Even if you drop an LED, it is not going to affect your LED. Then the lifetime of LED is roughly 75 years. Minimum you can have 50 years if you use it properly. Correct voltage, everything if you maintain. LED lifetime is roughly 50 years and above only. See, all are advantage: operational voltage, current through the LED, ruggedness. Then the lifetime, you see the lifetime. Once you fix a LED light, then it will come for 50 years. Minimum 50 years. And the last point is fast on and off switching. Fifth point, fast on off switching. Switching capability. See, the idea is, suppose if you give a square wave signal, you have a series resistance and then you have an LED, okay, maybe 1K. Now you have a very small, maybe this frequency can be 10 megahertz, 1 kilohertz, anything. That is the LED when during this time period it gives off light, forward bias, and here it is 0, no light. Then once again it emits light, no light. So the switching speed 1 kilohertz, 10 megahertz, anything. The LED spontaneously gives off light, no light, gives off light. So the switching speed is very high. But nothing will damage the LED. Because of high frequency switching, the LED will not get damaged. Whereas if you operate incandescent lamp with these rates, it will get immediately failed. Frequently on and off switching the incandescent lamp, immediately the bulb will go, incandescent lamp, filament will go off. Okay. So that's the drawback with incandescent lamp. You cannot use with a very high switching speed. So the life of the incandescent lamp will come down. But here, fast on-off switching capability is possible with the LED. Nothing will happen to the LED. Not only that, nowadays LEDs are used for communication purpose between one point to the another. So the current day world, what they are using is, in house and all, they are using LED bulbs or series and parallel combination of LEDs, so that signal can be transmitted and you can receive via the LEDs, apart from lighting the room. So you can use for communication purpose apart from lighting the room. So these are the advantages of LED. But I have covered only the main points that is listed in the NCERT syllabus, page 488, 12th standard. Hope you have understood all the 5 points. Thanks for watching. Nandri.